Lists and byte arrays are the first examples of mutable objects in Python I'll cover. Mutable objects can change their values. This has repercussions, as we'll see later, but it also introduces the possibility of creating non-pure functions by modifying the arguments passed into them. A list is a Python mutable array. That means you can add or remove elements from the array. A tuple, on the other hand, is an immutable array. Once you've created the tuple, that's it. It cannot be changed. You can create new tuples from it, but you cannot modify it. If you want to learn more about what I mean by array, I made a video especially about arrays. I encourage you to watch that. A byte array is a mutable array, but the values must be numbers between 0 and 255. It is comparable to the bytes object, which is an immutable array with the same values, 0 to 255. A list is to a tuple as a byte array is to bytes. There's also the string data type, which is an immutable array of Unicode code points. There is no mutable version of the string for reasons that I won't go into. They're very good reasons, though. In Python, you define a list much like you do a tuple, except you only use the square brackets, these guys. So this would be an empty list. And you can have some value in there, let's say the number 1, and that would be one element. Note that unlike for tuples, you don't need a comma at the end because there's no confusion with parentheses. You can also have multiple elements, of course, 1, 2, 3, and you can put optional commas at the end if you want to. That's a list with 3 elements. Note that we also use square braces for subscription and slices. So if I had a list called S and I wanted to grab an element from it, let's say the second element, so I would do this, and this is called subscription. And then we can also take a slice of that list. So we can see 0 to 1, and this is slicing. In practice, there's never any confusion between when you're declaring a new list and when you're doing subscription or slicing. As a side note, I've heard brackets called many different things, and I'm going to give you now their official names, along with some of the nicknames I've heard of them. So you know these as parentheses. We call this parentheses, we spell it P-A-R-E-N-T-H-E-S-E-S. So these are parentheses, and this is a parenthesis, okay? And the opening or left parenthesis is code 28. And the right or closing parenthesis is code 29. So we say left or opening, and we say right or closing parenthesis. And then we have square brackets. I used to call these square braces, but it turns out that's incorrect nomenclature. And the left or opening square bracket is code 5b. And the right or closing bracket, square bracket, is called 5d. And we also have curly brackets or braces. Okay, so these are curly brackets. You might hear squiggly brackets. In America, we call these braces. So we have the left or opening curly bracket. That's going to be code 7b. And the right or closing curly bracket, or the right brace, is called 7d. Okay, and you might, of course, have seen in mathematics or physics something like this. This is called bracket. So this is called the bra, and this is called the ket, and it has to do with statistics. We also have angle brackets. These are just the greater than and less than symbols, and so that would be code 3c and code 3e. And we call these angle brackets, but really it's just less than and greater than sign. And there are Unicode code points that are proper angle brackets, but we don't use these in programming. I've introduced comprehensions in a previous video, and we learned how to write a generator expression using a comprehension. So that is just a parenthesis with a comprehension on the inside, followed by another parenthesis. And this gives you a generator expression. If you need a brief review on what comprehensions are, that's basically you have some expression and it says for, and then you have some target list, and you have some in, and then an iterable here. And you can watch my video about comprehensions to understand the full syntax. For instance, you can have multiple for blocks, and you can even have if blocks. If you put square braces around a comprehension, then this is the list comprehension. What this does is it iterates through the comprehension, grabbing every single value, and then creates a new list from that. Let's look at a simple example. Let's say we had s is equal to I times 2, so I raised to the power of 2 plus j, for I in range, let's say 3, and then for j in range, let's say 2, and closing the square brace there, square bracket. This will give you the sequence 0, 1. So the first iteration, it's I is 0, j is 0. The second one is I is 0 and j is 1. And then we'll do I is 1 and j is 0, so that's going to give you 1. And then 1, 1 would give you 2. And then 2 would give you 4. And then adding one more would give you 5. So that would be the sequence there that the sequence S would be. Note that if your iterables here are generators that never terminate, then you should never do this because it will be bad for Python. You'll exhaust the sequence. Python will try to exhaust the sequence. The operators for lists are very similar to the operators for tuples. Let's go over them very quickly. So we have x in S, where S is a list and X is some value. This is a membership test. We also have X not in S, which is the opposite of the above. So it tests that X is not in the sequence S. We can also concatenate two sequences, two lists together. So this is concatenation. It will raise a type error if you try to concatenate different types of things together. We also have S star n and n star s, where n is an integer. And what this does is it does like duplication. So you might have like none times 5. Well, that's just going to be equal to none, 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 right? Then there is subscription we just covered. So that's S of I, where I is some index, and we have slicing, which is S and I of j, or you can have S of I, j, and k with colons in between. So, and the k version will do steps of k. Okay. The interesting thing about lists is we can modify them. So in our assign statement, we can have on the left-hand side a subscription. So let's say we do S of 1 is equal to some expression here on the right-hand side. Let me give you an example of what that might look like. So we have A is equal to 1, 2, 3. And then we assign, we say A of 1 is equal to 5. And what that does is it replaces the second element of A with the value 5. So we get A is now equal to 1, 5, 3, right? I'll just put that behind a comment saying that we're not actually assigning to A there. Now if we did like parallel assignment, so we can say A0, A2 is equal to the tuple 2, 9, okay? And there's not going to be an index or a type error here because this is a tuple. It's just looking for a sequence. And so after this is done, then A will be the same as 2, 5, 9. So you can change the values using list subscription on the left-hand side of an assign statement, whether that's a simple assign statement or that's parallel assignment. Okay. Note that if we had a list that was a nested list of lists, so let's use this example. So we have B where the first element is actually a list with 2 elements, and the second element is another list with 2 elements, and the third element is another list with 2 elements, right? And so we can actually assign, we can say we're going to take the first element, which is a list, and we're going to assign to the second element of that the value of, let's say, 7, right? And so now this 2 that was up here will now be a 7, okay? Note that we can also use negative indices. So I could say b of -1, so the last element of b, and in there I'm going to say the second to last element, we're going to assign that to 9. And so we go to the last element of b, which is this list here, and we take the second from the last. So this is the last, second to the last, and we reassign that to 9, okay? In addition to assigning to a subscription, you can also assign to a slice. Let me show you what that might look like. So in our example, we're going to have a of 1, 2, 3, and then we're going to say a from 1 to 2 is now equal to the sequence 4, 5. When you're assigning to a slice, you always need to assign a sequence. If you don't assign a sequence, Python will raise a type error, okay? And what this does is it takes the sequence here, it looks it up, and in this case, this sequence says start at the second element, so right here, and then go to the third element, so right here. So this area here. And it removes it from the list altogether. So this is going to be eliminated. And then where that list used to be, it's going to put in the new sequence. So A is now going to be equal to 1, 4, 5, 3. Okay? If you were to assign an empty list, then you would just be removing those elements altogether. And if you are assigning to an empty slice, for instance, if I wrote code like this, let's say a from 1 to 1 is going to be equal to 7, 9, then what would happen is it would go to that place, remove the elements where there are no elements in that empty list, and so it's just going to insert those elements at that position. So we're going to have 1, 7, 9, and then we have 4, 5, and 3. Okay? We can use this, and we typically do, when we want to replace the entire sequence. So let's say I wrote the code a from nothing to nothing. We could put none, none if we wanted to, is now equal to the range from 4 to 7. And so now, after this statement runs, a is going to be equal to 4, 5, 6. Okay, so we do this more often than you think, where we replace the contents of an array. If your slice is out of range, that's okay. If it's beyond the end, it'll append to the end. If it's beyond the beginning, it'll prepend to the beginning. And note again that if this right-hand side is a generator, Python's going to try to exhaust that sequence. So if it's not going to exhaust, you're going to have problems in your program. Okay. We've seen before the del statement. So we've seen it used to remove variables. In this case, if I said del a, that would remove a from the namespace. And so if you referred to it again, it would raise a name error. We can also use del to remove items from a list. So let's say we have a is equal to 1, 2, 3, and we say del a of 1. So that's the second item there. And what that's going to do is removes the second item from that list. And so now the list is 1, 3. And then we could even delete ranges. So if I said del and a, let's say I'm going to go from the end to the end, then that's basically removing the entire list, and now the list is empty. Okay. Well, let's cover some of the functions that can use lists. First, we have the list function. This will return an empty list, a brand new empty list every single time. There's also list, where you can pass in some iterable, and this will give you a new list. If you passed in a list, it would give you a copy. If you just passed in some sequence or some generator, it'll actually try to exhaust all the items of that and create a new list from it. And there are several other functions that work with sequences. They also work with lists. We have all and any. And what these will do is check that every value in the sequence is true, and this one will test if any value in the sequence is true. If that's true, then this is true, otherwise it's false. Of course, we have our friend enumerate, one of my favorite functions in Python. And we pass in some sequence there. It'll give you back a list of tuples where the first is the index and the second is the value. And you can also call enumerate with the optional start parameter. So you can say start at index 2, right? This is particularly good if you're slicing from the list. There is filter, which takes a function and a sequence, and it applies that function to each element of that sequence and returns an iterator that will only return the values that are true. Of course, we can convert lists to an iterator using the iter function, and we can find out how long a list is with the len function. We have the map function that we've talked about before, where it takes a function and one or more sequences, and it'll apply that function to elements from those sequences, and if there's multiple sequences, they'll be passed in as different parameters in the function, and returns a new sequence, a new iterator that will give you each element from that. We also have max and min. These will return the largest and smallest values from that sequence. We can reverse the sequence and return a copy of it. This won't actually change the list, but it'll return a copy of the list, but in reversed order. And then we have sorted, which we can take a sequence. We'll talk more about sorted and reversed in another lecture. And then we have sum, where you take a sequence and you can have some starting value. Optionally, it starts with 0. We'll add all the elements of the list together. If you wanted to create a string from this, I encourage you to use join, the string method join on the sequence. Okay, that's a preferable method. And then we have tuple, which will take some sequence and give you a tuple. And we also have zip, which will take multiple sequences, combine them together in a new sequence where each element is an item from each of these sequences. Okay. There are lots of list methods, but not so many as strings and bytes have. They are the following. We have s.append, and that takes a single parameter and adds that to the end of the list. That item will be at the end of the list when that function method runs. Then we have extend, which takes another sequence t and will expand s with the last elements being the elements from t. So it's basically combining these together, but doing it in place. So that's not the same as adding the two sequences together. This will create a new list. This one will extend the list to include those elements from t. We can insert elements at arbitrary locations using insert. So we pass in the position we want to insert the element in and the element we want to add. We can entirely clear the entire list using the clear, which will basically change the list so there's no elements in it anymore. We can create a copy of the list. This will return a new list that's exactly the same as the old list. We can pop the last value off the end of the list using the pop method, or if we wanted to pop from some other position, we can pass in the position using I. This will raise an index error if the list is empty or that's an invalid index. We can remove items by their value. So this will search the list S for that value X and remove the first one it sees. We can count the number of times that the value occurs using the count method. We can also find where the value is in the list using X, and we have the optional start and end or stop parameters. These are optional, you don't have to specify them, but that'll look for X in the list and tell you where it is. And then finally we have reverse and we have sort. We'll cover these in the sorted and reversed lecture later on. Okay, so we can kind of group these together. So these functions here, they add more elements, right? So append adds it to the end, extends adds an entire list of elements or sequence or whatever, and then we can arbitrarily add it inside a certain position using the insert. Note that we really need to be careful here with nomenclature. We often say something like add an element to the list. And this is precise enough. The problem is that we sometimes get lazy and we might say something like add to the list. And newer programmers or people that are being pedantic might say, what do you mean? You're going to take the list and you're going to add 2? All right, let's write that out again. You're going to take S and add 2. That doesn't make any sense. What this means is you're adding the element with the value of 2 to the list. Okay, so rather than saying add, try using the word append. Append 2 to the list. And this is very clear language. Everybody understands that. So try to avoid using the word add in relation to lists because of the confusion that might arise. There are two functions that are used to remove elements from the list. So the pop and the remove are used to get elements out of the list. Note that remove doesn't return the value, and it only removes the first time this value occurs. If there is no value in the list, then it will raise a value error. So here is a little bit of code that will remove all of the values. So let's say we want to remove all x's from the list. Oh, I need to pass in the list too. So s comma x. So we say while true, then we will try to do s.remove x. And if we have the value error, then we will break out of this loop, break. Otherwise, we'll just continue through and keep removing values. So that's some simple code there. So copy is pretty self-explanatory. There's actually three ways that you can copy. Let me write these down. One is we can say s.copy, and that will create a copy of the list. We can also just do this, s, and take a slice, and that creates a copy of the list as well. And of course, we can use a list comprehension. We can say x for x in s, and that will create a copy. Of all of these, I prefer using the explicit copy, although I see this quite often in Python code. You can also clear a list, and there's a couple ways to do this as well. So we could say s.clear. We could say s, and then this is equal to some empty list or sequence. And then finally, we can say del s and the full slice there. Of all these, of course, I prefer the explicit clear method. Lists can be used to make stacks and queues. Let's talk about stacks and queues. So a stack follows what we call first in, last out behavior, FILO behavior. So we will push items onto the end of the stack and then pull them off the end of the stack. Okay? Whereas a queue follows FIFO behavior. First in, first out. So we push items onto the end of the queue and we pull them off the beginning of the queue. Both of these can be represented with lists, and I'll just kind of give you some sample code here to show what that might look like. So for a stack, we might have a push function that takes a list and some item. And what this will just do is append the item to the end of the list. And the pop function will take the stack and it will return the stack with the last element popped off. Okay. For the queue, the push is the same. Let's just write that out. We're going to say s.append x. And then when we go to pop, from the queue, we have to pop from the beginning. So we're going to say return s.pop at 0. So that's how you do stacks and queues. They're very common data structures that you'll see used again and again and again. Let's talk about byte arrays. Byte arrays behave exactly like bytes and also allow for assignment to subscription and slices like lists. You, of course, have the byte array function that has the same signature as the bytes function. So you have some source, which can be a string or it can be a sequence, an iterable, and then you can optionally specify the encoding and what to do if there are errors with the encoding. So this defaults to UTF-8 and it defaults to strict. Like bytes, byte array elements are integers and must be between 0 and 255. And when you do subscription on a byte array, it's going to give you back an integer. If you try to assign a value that's outside of this range, it will raise a value error. Many of the list methods are missing from byte array. For instance, it has reverse, but it doesn't have sort. I haven't used byte arrays for anything professional yet. I don't know that if this is a good thing or bad thing. Okay. If I did want to use a list of integers, I probably would just use a straight up list. There's also libraries like NumPy if you want to manipulate large lists of numbers. Let's talk about some odd behavior that might arise when you're using for loops and mutable sequence. Let's take a look at an example. So let's say I had for I, comma v, and enumerate some sequence s. Okay. If, as part of this enumeration, I were to modify s, let's say I were to insert at the position I the sequence 1, 2, 3. Now what will happen here is it will grab the first element from the sequence, give you I, v, I is 0, v is that value, and then at the 0th position it's going to add 3 new elements. And so it's going to grab the next element from that sequence. Well, what's the next element? It's 1. Okay, so it's going to say 1, 1, and then at the 1 position it's going to insert the sequence again. And then it's going to grab the next element, which is going to be another 1, and it's going to do this infinite loop. Okay? This leads to unpredictable and surprising behavior because the list is being modified as you're iterating across it. And this typically arises when you least expect it. For instance, I've done something like this many times. So let's write a remove all function. We're going to take some sequence x, s, and we're going to remove the elements x from it. And so we'll just iterate through this sequence, and we will remove those elements. So we're going to say if v is the same as x, then we're going to delete that ith element. We could use pop as well. Okay. Now the problem arises because as we delete the element, it's going to look at the next element and it's going to skip the element that was actually next. Let me show you what that means. So let's say I had the sequence 1, 2, 2, 3, 4, and we're trying to remove the 2's. Okay. So the first time through, it's going to say I is 0, v is 1, though that's not equal to 2, so we're not going to do anything. The next time through, it's going to say I is 1 and v is 2. So 2 is the value we're trying to remove, so it's going to delete this element from the list. Okay. Now the next time through, it's going to look at the third element. So 0, 1, 2. So it's going to return 2, 3, and it's going to skip this 2 altogether. Here's one way to handle this issue. I'm going to give you actually 2 different ways to handle it, but here's one way. We could rewrite this function like this. So we could say that s is replaced with the contents of the list comprehension v for vns if v is not equal to x. Okay, and this will do what you want, but keep in mind what you're doing is you're building up a new list and then replacing the old list with this. Here's another way we can implement that function. So we say def remove all x from the list s. And so what we'll do is we'll have a new sequence that is an empty list. And then for each item in s, we're going to see if v is not equal to the value that we're looking for. Then we're going to add that to the new s. And finally, at the last step, we will replace s with that new s sequence. So that's basically the same as the example with the comprehension as well. The general pattern is to avoid iterating over something that you're modifying. Just make a new list from build up a new list that looks like the thing you want and replace it if you need to. Let's talk about some subtle things that happen when you call a function with a mutable object. So as an example, I'm going to write a very trivial example. I'm going to write a function called append that takes a sequence and adds the element x to the end of it. So it's just going to call the method append with x on the end. Okay. And of course, when we call this method, let's do some sample code over here. So if we had our a is equal to 1, 2, and then we call append, the function we just wrote, on a, 3, then that's going to mean that a is now equal to 1, 2, 3. Okay. Now, if you're coming from a different programming language, this might be somewhat confusing about what exactly is going on here. And some of these misconceptions might creep into your program and cause you to make some bad decisions or do some weird stuff that you don't need to do. Okay. First rule is 1. Variables do not contain values. Variables do not contain values. Variables if they have a value at all, it's actually the location or a reference to, or if you're from the C, C++ world, it's a pointer to an actual object somewhere in memory. Okay? When you're passing a variable into a function, you're not actually passing the variable in, you're passing the thing that that variable references, right? So this append function, if it exists at all in C, would be accepting a pointer to a Python object and another pointer to a Python object. Okay? Some languages, the variables actually contain values. For instance, in C or C++, if I said like int a equals 5, then what that does is in memory, it reserves a spot for that 5, and then a is a reference to that spot. And when you call a function with a, what it's actually doing is taking the 5, copying it, and passing it off to the function so it can stick that into its own memory. Okay? So Python doesn't copy values. If it copies anything, it's only copying the reference to the objects that it's passing in. Another thing that we sometimes say is that this function changes a, right? I guess this could be technically true, but it's not. Okay, so we need to say that Python functions cannot change variables. And what I mean by that is, let's say we had the following code. So we said a is 5, and then we're going to call some function on foo on a, and then somehow we're going to get a is now equal to 6. Okay? This is impossible in Python. The reason it's not possible is because 5 is an immutable object. And when we pass that 5 into the foo function, it can't change that 5. Right? So this variable will always be assigned to that same object, and you can't reassign the variable as part of that function. Right? Now the only reason this works is because this list is mutable. When we pass it into the function, it can get changed. And so a hasn't changed at all. Append is doing nothing to a. It's only changing the object that a references. Okay. Given the above fact, we sometimes get lazy and say append changes a. Okay. Although it's not necessarily precise, it's technically what's going on here, because a is referencing an object and append is changing that object, and so yes, a is changing. Okay. Anyway, guys, I hope this was helpful. If you have any questions, please ask in the comments below, and you can find me on Discord so we can talk more about this subject. This is a really subtle point that I think confuses a lot of new programmers, especially coming from C, C++, and Java. Have a great day. Take care, and bye-bye. Thank you for watching this video on the theory of Python by Real Physics. Be sure to subscribe and ring the bell, like and share this video. You can find me on Discord or support me on Patreon. Links are in the description below. Thank you so much. Have a great day. Bye-bye.